Hello. I was not with you today because I stayed home to be with my daughter who's in town for like 3 days. And she's like 8 months pregnant, and I wanted to spend some time with her and her husband. And I took the day off, and I hope that you were able to make some progress on this leap day with your probability problems. I was wondering, what's the probability of that? Well, we may wrap that up tomorrow, but either way, I'd like you to take some notes on our new topic. We do have to have a concluding activity on probability and counting, which will take the form of a worksheet that you will do at home or on your own time. And you may use your notes in your book, but not each other, to answer questions somewhat like we've been practicing. But more on that tomorrow. And so I'll give you several nights to accomplish that. Meanwhile, we will make some progress tonight on our next topic, and that is going to be, let's see if I zoom on away here. I have blue light here. I have that problem when I'm sitting here. Let's see. I'm just going to talk for about 15 minutes and just stop, wrap it up at whatever time that is, because I have to be out and about. Sorry, it's kind of blue, but I think you can at least read it. Write this statement. The blank is a set of all points equidistant from a fixed point and a line, and I'm assuming they're in the same plane. So what is that defining? We'll fill in the blank by investigation. You can pause it if you need time to write that down. So here we are on a coordinate plane, and I'm going to kind of sketch what these words said. It said there was a point and a line. So let me give myself a line and a point. It didn't have to be there, but that's an example to help us figure out what this figure is. So here's my fixed point, here's my fixed line, and I want all the points that are equidistant between these two. So one of the ones that is the same distance or equidistant from this point as this line is the one right in between. So I'll mark it with a little X. So what if we go out in this direction? So if I go from the point to this other X, and I want this distance to be same as this distance. The distance to a line from a point is measured perpendicularly. Let's see if you can see that a little better. All right, that doesn't look too good. I'm trying to make this look the same length as this. So maybe if I put that little X up higher, we will have something that looks more equidistant. Somewhere over here, there's a point that's the same distance from this point to the X as it is to the line here. All right, it's kind of funny. I kind of have because I'm at an angle, see when I look straight down, it looks like more like they are equal. When I come back here where my thing is standing, this looks a lot longer. So on your paper, draw an X that looks like this distance and this distance are the same. If I call this D1, this would also be the same distance, D1. All right, so the perspective you're looking at this through the lens looks like they are not, but they actually are. So that's another point maybe up here where the distance from here to there, say that's D2, is the same as here to there. And maybe that one looks a little more convincing. So, and then there's another one, and that works the same over on this side. And when we have all the points that meet this requirement, we are smiling because we are looking at a smile, and that is called a parabola. All right, so go back and fill in the word parabola. A parabola, then, is the set of all points equidistant from a fixed point and a line. So let's go a little deeper. This fixed point has a name, and that is called the focus. And this fixed line has a name. It is called the directrix. The focus and the directrix. So indicate that. I'll try to check your notes tomorrow, so if you don't have your comp book, please write them on a paper and bring it in. So I'm going to record who does that. Let's look at some more about that. Halfway between the focus, so on my sketch, this is the focus, right there, and halfway between the focus and the directrix, that's right there. So halfway between here and here, there is a point that you have met the name of this point before, and that's called the vertex. So halfway between the focus and the directrix is the vertex. All right, and hopefully that makes sense to you. Now, I've kind of alluded that this is what a parabola always looks like, but it does not. It can also open. This is called open upwards. It can open downwards. And so far, in the way that you have learned parabolas, you have pretty much limited your study, I believe, to those that open upward and downward, but the way we're going to look at it this year is they can open to the right and they can open to the left. So, all right, with that in mind to look forward to, let's start with the simplest formula for that. So, the simplest formula for is when the vertex is at 0, 0. So when the vertex is at 0, 0 and it opens upward like this, so we're going to have the vertex at 0, 0, the focus somewhere like that, and it opens upwards. The equation for that is x squared equals 4py. Let's go back to our original picture up here and find p. I talked about focus, vertex, and directrix, but no p. P is the distance from the focus to the vertex. So that is p right there. So let me jot that down. P is the distance from focus to the directrix. All right, up here, in this case, when the vertex is above the focus, like it would be when it opens downward, this P would be negative. When this opens to the right, here's the focus, here's the vertex, this P is positive, and this P is negative. So a negative opens left or downward, a positive P opens upward or to the right. All right, so with that in mind, let us see what this equation tells us also when the x term is squared, the y term is not. When x is squared, that means we have a vertical parabola. What's one that you're used to studying? One that opens either upward or downward. So that leads you to the thought, well, what's it look like if it opens left and right? And probably, as you may suspect, y squared equals 4px. So when y is squared, when y is squared, we have a horizontal parabola which opens left or right. Let me write down that stuff I said about p here. So where shall I put it? So when p is positive, I went over this, but I didn't write it down, so let's get it in our count book. When p is positive, the parabola opens upward or to the right. And now we know how to tell which of these it is by whether the x term is squared or the y term is squared. When p is positive, it opens upward or to the right, and when p is negative, opens downward or to the left. And we can tell which one it is because now we know by which term is squared what kind of parabola opening upward or to the right, downward, or to the left we're looking at. Alright, so putting those two together we know a whole lot, but we don't know everything in every case. So let me give you a little bit more. Looks like I'm approaching 15 minutes. It turns out that a lot of parabolas are not centered at the origin. So that's one that is, but let's say we have this vertical one that opens upward is going to be moved so that now its vertex is over here and the focus is over there. Notice the parabola always goes through the vertex. It never touches the focus, but it envelops it. I always wanted to use that word. It surrounds it, it protects it. So no matter which way you go, so when you look up here at these parabolas, here this vertex is, the parabola went through it, but the parabola envelops, or doesn't touch it, but it protects the focus. It envelops it and it opens to the left. That's the focus. Here's the focus, envelops it when it opens to the right. Alright, so there's a new formula for when the parabola has left the vertex at the origin. And it turns out if we moved over, say, h, and we went up k from the origin to get to the new vertex, the equation looks very similar because this one was x squared equals 4py, 4py. And now because we moved it over h and k, the h is how far the x moved, and it will attach to the x variable with a negative sign, the opposite sign, and 4p, and since we moved up k from the origin to get to the new vertex, we're going to do y minus k. So we used to call these Hector and Kyle. That's just my class, not any other class, because Hector and Kyle would like to come out and play a lot. So here's how they come out to play with parabolas. And that goes the other way. Again, since the x term is still the squared term, that means it's a vertical. It opens up or down, depending on whether p is positive or negative. And the other way is y minus k, quantity squared, equals 4p x minus